looking at an interesting application, but measuring the thermal, and also we're going to take a look at the mechanical properties of condoms. There's been some interesting work in next-gen condoms introducing additives and fillers like graphene. Hydrogels aren't what I would say necessarily new. They've been around for quite a while, but Dr. Robert Gorkin, who's a researcher at a university in Australia, is actually pioneering some research on the development of hydrogel-based condoms, which has some interesting applications. Hydrogels, there is a lot of work being done in industry, in industry and also in academia for using hydrogels as biomedical scaffolding materials. So you can actually impregnate the hydrogel with a specific drug, antibacterial, different for drug delivery in a variety of applications. But for use in condoms, where a lot of those the lubricants or some of those medications are being coated on the condom itself for improved protection and health considerations. Now, I also wanted to touch on another thermal property, thermal effusivity. This is one that, if you've been on our webinars, we talk about a lot in terms of the warm feel, cool touch of a sample. Thermal effusivity is sometimes referred to as thermal inertia. It defines a material's ability to exchange heat with another body that it's in contact with. There's been some work done in collaboration with C-Therm and a few different industry or academic researchers. This has been featured in some previous webinar content, but work with the University of Oregon, taking a look at really correlating the perception to of a human touch panel to the effective thermal effusivity of these materials, in trying to, again, quantify where do the effusivity values line up with the perceived feel of a human subject. So on the far left there, you can see the TPS thin film setup. Again, quite simply, the TPS sensor with that conductive metal backing, which is a stainless steel, and then some of the condom that was placed on the top and bottom side. But from a results perspective, we can see that comparing the latex and the non-latex versions, there was a notable difference in both the thermal conductivity measurement tested on TPS and a very similar trend observed in the effusivity from the MTPS. So again, kind of showing that the non-latex version actually was higher in thermal conductivity than the latex counterpart.
Simplifying thermal conductivity.